Hello friends, welcome back to my channel Learning Physics with Bhavya ma'am. Today we are going to solve Model Question Papers 2 Numericals. The first numerical is 2-point charges of 4 nanocoulomb and 8 nanocoulombs are placed at the points A and B respectively, separated by distance 0.2 meter in air. Find the magnitude of resultant electric field at the point O of line joining A and B. What will be the magnitude of resultant electric field at O if 4 nanocoulomb is replaced by another plus 8 nanocoulomb of charge? So first let us consider two charges. Two charges are placed here at points A and B. At A and B, plus 4 nanocoulomb and plus 8 nanocoulomb are separated by distance of 0.2 meter in air. So let us consider this is a midpoint O. Find the magnitude of resultant electric field at O. So each charge, let us consider this is Q1 and this is Q2. Each charge produces electric field at O. So since these two charges are positive, then here we need to assume one test charge which is also positive. So what happens? This positive charge repels the test charge. That means this will be the direction of electric field. Electric field due to first charge is away from it. So this is a direction of E1, away from it. Similarly, electric field due to second charge is away from that. So this will be the direction of electric field E2. Why? Because you need to assume one test charge. You need positive test charge here, 1 coulomb. Okay. So that the force along which unit positive test charge is moving. Okay, the direction along which unit positive test charge experiences force. In that direction we need to write electric field. So the positive charge pushes this unit positive charge, so it repels in this direction. Therefore E1 is acting in this direction. Similarly, second charge also repels the unit positive test charge in this direction. That's why E1 and E2 are in opposite direction. Then what is a resultant electric field? So resultant electric field at O is E is equal to, it is a difference, E2 minus E1. Difference between these two electric fields, E2 minus E1. Now let us calculate electric field E1. Electric field at O due to Q1 is E1. How to calculate? It is 1 by 4 pi epsilon naught Q1 by the distance. So the distance is A to O. Square it. Okay. Electric field is inversely proportional to square of the distance. Q1 by AO square. Right. So it is 9 into 10 to the power 9. Q1 is 4 nano 10 to the power minus 9 divided by the distance, half of the distance, right? So the total distance between two charges 0.2 meter. O is a midpoint of line joining two charges. So half of the distance is 0.1. 0.1 square it. Okay. 0.1 square means it is 10 to the power minus 1. Square is 10 to the power minus 2. So 9 4s are 36 and 10 to the power 9 and 9 minus 9 cancel. So it is 10 power minus 2. When it comes to numerator, it becomes plus 2. So E1 is 36 into 10 to the power plus 2 Newton per coulomb, because electric field is nothing but force acting on unit positive test charge. Electrostatic force on unit positive test charge. So Newton per coulomb is a SI unit of electric field. Right. Similarly, let us calculate E2. E2 is 1 by 4 pi epsilon naught Q2 by the distance. The distance is B to O whole square. So again 9 into 10 to the power 9, 8 into 10 to the power minus 9, and the distance is 10 to the power minus 1. 0.2 half is 0.1, that is 10 to the power minus 1, square it. So minus 2. 8 9s are 72 into 10 to the power plus 2 Newton per coulomb is E2. Therefore, what is the resultant electric field at O? It is E2 minus E1, or you have to subtract the smaller one from bigger one. So it is 72 minus 36 into 10 to the power 2 is common in both. 72 minus 36 is 36 into 10 to the power 2 Newton per Coulomb. So resultant electric field is 36 into 10 to the power 2 Newton per Coulomb. Okay. Then what is the direction? So here the question is find the magnitude. Only you have to find out the magnitude. If the question is find the direction of resultant electric field, means the resultant electric field is always acts along the direction of greater electric field. So here E2 is greater than E1. So therefore resultant electric field is along the direction of greater electric field, which is E2. Okay. Now suppose if you replace 4 nanocoulomb by 8 nanocoulomb, what will be the resultant electric field? So here instead of 4, if I write 8 nanocoulomb, then what happens? So let us consider here the at A 8 nanocoulomb is placed and at B 8 nanocoulomb, both are positive. Okay, and we need to find out electric field at O. So plus 8 nanocoulomb produces electric field away from it. So this second one is also produces electric field away from it. So E1 and E2 are in opposite direction. Okay. Now the resultant electric field is E2 minus E1. But what is the expression for E1 or E2? It is 1 by 4 pi epsilon naught Q by R, right? So both the charges are same and both the distance are same, right? Q1 is equal to Q2 and A2O is equal to B2O. Therefore, E1 is equal to E2 and they are in opposite direction. So, electric fields are equal and acts in opposite direction, means total electric field is 0. Resultant electric field at that point is 0. Like this. This is a first question. Okay. So, don't get panic. Practice thoroughly. You have to practice all the important questions which we solved, okay, or which is there in NCERT textbook, and go through the questions properly, read the questions thoroughly and use appropriate formula, okay, and write neatly. So each steps carries marks. Formula which carries 1 mark, substitution and getting the answer 1 mark, again formula 1 mark, getting the answer 1 mark. So you will get 4 marks for getting this answer and 1 mark for this. Total 5 marks. Now let us move to the next numericals. Find the currents I1 and I2 in the given electrical network. So here you can see two loops. Each branch is having resistors AB, BE, and this branch is having resistor, and this branch is also having internal resistor. Okay, and here you can see one cell of voltage EMF 4 volt and internal resistance 2 ohm. And here also in this mesh you can see each branch is having resistor. This branch is having cell as well as internal resistance 1 ohm, and each branch is having resistor, right? Look at the direction of current. Battery current always starts from positive of the cell. So positive of the cell, I1 is flowing like this. This is I1, and as it comes to the point B, here I1 is entering the point B and I2 is also entering the point B, whereas I3 is leaving. So therefore at node B, if I apply KCL at node B, then total current entering is equal to total current leaving. The current entering is I1 as well as I2 is equal to total current leaving, which is I3. I3 is leaving, right? So similarly here, say from this cell, I2 amount of current is flowing. So current always starts from positive electrode. Okay, so it starts from like the positive of the electrode and it is moving like this. And as it comes here at node B, I1 and I2 together, which is I3 is flowing. And at this point again at E, So what happens here? I3 is entering and I1 is leaving, and here I2 is leaving. Okay. I3 amount of current entering is equal to total current leaving. I3 is entering, I1 and I2 are leaving. So I1 plus I2 is I3 at this point. Okay. So here if you look at this branch, I1 is flowing and in this branch I2 is flowing. Now first let us consider the direction of traverse. I'll move in clockwise direction in first one. Okay. So applying KVL to loop, which loop? A, B, E, F, A. So you have to write IR product. Which current is flowing? I1 and 6 I1. When you are moving in the direction of current, then IR product is positive. So 6 I1 is positive. Then we are going down. So that is 10 I3. 10 I3 is also positive because current is flowing in downward direction. We are also traversing the network in downward direction. First branch AB, next branch is B to E. B to E. We are going down, current is down. So that is 10 times I3. But how to write I3? I1 plus I2. You can avoid one step. Okay. So it is directly, let us write, instead of I3, I will write I1 plus I2. Plus one more is there here. So we are going in this way. So current is also flowing along same direction, which is 4 times I1. And here there is an internal resistance. Don't forget to write this, student. So it is 2 times I1 plus 2 times I1 is equal to IR product is equal to summation EMF. So here there is a voltage, the EMF, right? So when we are moving in this direction, when we are moving towards the positive of the cell, then EMF is positive. So since we are moving towards the positive of the cell, therefore EMF is positive. So it is plus 4. Now let us simplify it further. 10 I1 plus 6 I1 is 16 plus 4 I1 20, 22 I1. So it is 22 I1 plus 10 I2 is equal to 4. You can divide throughout the equation by 2, then it is 11 I1 plus 5 I2 is equal to 2. Call it as equation 1. So the equation is 11 I1 plus 5 I2 is 2. Now let us apply KVL to the second loop. Applying KVL to the loop, B to C, C to D, D to E, E to B. Check the currents. So we are moving in this direction clockwise. So B to C, in that current is going in opposite direction. So it is IR product is negative. So 6 I2 minus 6 I2. Again we are going down but current is up. So IR product is negative. So 1 I2. 1 times I2. So in this loop, current is IR product is negative because current direction and the traverse is opposite. That's why it is negative. So here D to E 4 times I2, which is also negative. 4 I2 negative. Again we are going up, current is down, so it is negative. 10 times I3. 10 times I3, let us write I1 plus I2, that is equal to EMF. So we are going down towards the, see, positive to negative. Towards negative means EMF is minus 2. EMF is also negative. First let us simplify it. So minus 10 I1, there is only one I1. So it is minus 10 I1. And 6 I2, 7 plus 4, 11. 11 plus 10 is 21. Minus 21 I1, sorry I2 is equal to minus 2. So you multiply by negative or cancel negative terms. So it is 10 I1 plus 21 I2 is equal to 2. Let us call this as equation 2. Now let us simplify these two equations. So here you can see 11 I1 plus 5 I2 2. This is 10 I1 plus 21 I2 2. So to simplify it, let us multiply equation 1 by equation 1 is multiplied by 10. Then it becomes 110 I1. 11 into 10 is 110 I1 plus 50 I2 is equal to 20. Similarly, equation 2 is multiplied by 11. So, once again you will get, here I'll write equation 2 is multiplied by 11. So, it is 110 I1 plus 11 into 21. 11 into 21 gives 231 I2 is equal to 22. To simplify it, so here let us write negative, negative, minus. You have to subtract this. So subtracting these two cancels, minus 231 plus 50 becomes minus 181 I2, that is equal to minus 2. Therefore, I2 is equal to minus minus cancel. So 2 divided by 181, 2 by 181. That is, if you divide 2 by 181, you will get 0.011 ampere. 0.011 ampere. Now let us substitute this I2 value in one of the equation, any one. Let us get write in equation 2. Substituting I2 in equation 2. So 10 I1 plus 21 into 0.011 is equal to 2. Simplify it. 10 I1 plus 21 into 0. Becomes 0.231. So 10 I1 is equal to 2 minus 0.231, that is equal to 17. So after simplifying you will get I1 is equal to 0.1769 ampere. 1769 ampere. This is clear, student. Here we got two equation and we solved it. There are two variables and two equation. So we solved like this, right? So you are familiar with how to solve two equations if there are two variables. So like that, using this method we got this answer. So you can also use Kramer's rule. So you have to write I1 and I2. First equation is I1 is 11 and I2 is 5. Okay. And here in second equation it is 10 and 21. 10 and 21. So after multiplying 11, 21, 21 into 11 you have to multiply, that is 231 minus 5 into 10, 50. So it is 181. Okay. And next, so to find out delta 1, you have to replace this I1 by right hand side term. Replace this I1 by right hand side, that is 2, and here it is in equation 2 it is 2. So 2 and 2, 5 by 21, keep as it is. 21 into 2, multiply, cross multiply like this. So 21 into 2 is 42 minus 10, that is 32. So therefore, similarly calculate delta 2, that is replace the second column by 2 and 2. So cross multiply, 11 into 2 is 22 minus 10 into 2 is 20, that is 2. So how to calculate I1? I1 is equal to delta 1 by delta, that is delta 1 is 32 divided by 181, which you will get 32 by 181. Let us solve that. 32 divided by 181 gives I1 0.1767679, okay, ampere. Similarly, delta I2 is equal to delta 2 divided by delta. Delta 2 is 2 divided by delta is 181. So 2 by 181 is 0.011 ampere. Like this, using Kramer's rule, we can find currents. So you can use any one of the method which you will find easy. Now the third question is AC chapters. A series LCR circuit contains pure inductor of inductance 5 Henry. Inductance is 5 Henry and capacitance is 20 microfarad. Resistor of resistance 40 ohm. AC source of VRMS 200 volt. RMS voltage is 200. Frequency is 50. First step is you have to write the given data properly. Find impedance. So what is the formula to calculate impedance? Z is equal to square root of R square plus XL minus XC whole square. So for that, first calculate XL. XL is omega L, that is 2 pi f L. So 2 pi is 3.14, f is 50, L is 5. So here 2 into 50 is 100, 3.14 into 100, 340 into 5. So 5 4s are 20, 2 5 1s are 5, 2 7, 3 5s are 15. So it is XL is 1570 ohm. Next, XC is equal to 1 by omega C, which is 1 by 2 pi f into C. So 1 divided by 2, pi is 3.14, f is 50, C is 20, micro 10 to the power minus 6. When it comes to numerator, it becomes plus 6. Once again, 2 into 50 is 100, so 314 into 20. So 10 power 6, 314 into 2 is 628. 628 into 0, 6280. So you have to divide this 1 by 6280, multiply by 10 to the power 6 into 10 to the power 6. So that gives 159. I'll calculate it first. So 1 divided by 6280 into 1, 2, 3, 4, 5, 6. So you get 159.235. It is, let us write 159. 159 is enough because the next number is 2, 3. Since it is less than 5, no need of writing that. So it is 159 ohm. So if you write digits, decimal digits, point something, then there is a small variation in the answer. Okay. Some digits, there is a last digits maybe change. Okay, so there is a variation in the last digits, no problem. So now let us calculate Z. Z is equal to square root of R square. R is 40 square plus XL minus XC. XL is 1570 minus XC is 159. Square it. So now let us calculate 40 into 40, that is 1600. 4 square is 16, 1 square is 00 plus, first let us calculate 1570 minus 159 is 1411. 1411, square it, 1411, that is you will get 1,990,921. Now add 1600 and then take square root of this. So that is square root of 1992521. Square root of 1992521 is 1411.567. Okay, you can write it as 1412 ohm. So Z is this much. Okay, 1412. impedance is this much. Is this clear? So you have to practice some calculation. And XL is omega L, XC is 1 by omega C. Next, also find resonant frequency of the circuit. Resonant frequency is F naught is equal to 1 by 2 pi root L into C. That is 1 by 2 pi 3.14 into root L is 5, C is 20, micro is 10 to the power minus 6. So you can write this as 2 into 3.14 is 6.28 into square root of 5 2s are 10 into see 20 into 5 is 100, 10 to the power 2 plus 10 to the power minus 6 is 10 to the power minus 4. 10 to the power minus 4 square root is 10 to the power minus 2. When it comes to numerator, it is 10 to the power plus 2. 10 to the power plus 2 is 100. 100 divided by 6.28. 100 divided by 6.28. Let us calculate. 100 divided by 6.28 is 15.9. 15.9 hertz. 15.9 hertz is the answer. The next question is, an object is placed at a distance 0.3 meter from convex lens of focal length 0.2 meter. Find the position and nature of the image formed. So here we are having one convex lens, and an object is placed at a distance 0.3 meter. At a distance 0.3 meter, object is placed, U. So in convex lens, see this will be the direction of incident ray, and we are measuring the distance like this, right? So in opposite direction, that's why U is minus. Whenever object is placed in front of the lens, U is negative. So it is minus 0.3 meter. Object is placed at 0.3 meter from convex lens of focal length. Focal length is 0.2 meter. Convex lens is a converging lens, right? Converging lens. Hence, the focal length is converging lens and focal length is positive. So 0.2 meter. To find out the position of the image, we are using lens formula. So what is that lens formula? Using lens formula, 1 by V minus 1 by U is equal to 1 by F, or 1 by V is equal to 1 by F plus 1 by U. Substitute now. 1 by F is 0.2 plus 1 by U is minus 0.3. So its LCM is 0.2 into 0.3. So you can write it as 0. Multiply this 0.06, cross multiply, minus okay, 0.06 is LCM. So cross multiply 0.2. So here it should be 0.3. Now here there is a positive into negative is minus. 0.3 is already we have written. So into 0.2. Is this clear, student? So don't confuse here. First take LCM. 0.2, 0.3 LCM is 0.06. And already I have written 0.2 means you have to multiply by 0.3 here, right? And plus into minus is minus 0.2. So that is 0.1 divided by 0.06. So 1 by V is equal to 0.1 by 0.06, or you can cancel 1 point, okay. So 1 point cancel, that is 1 divided by 0.6. Or you can write, say, is this clear for you? 1 point cancels, or V can be written as 0.6 meter. So here we get the answer plus 0.6 meter means the image forms here, this side, right? Other side of the lens. Since there is a plus, V is plus means the image forms this side, and here it is inverted. The image is, what is the nature of image? Image is real, inverted. Real and inverted. And what is the distance? It is 0.6 meter. 0.6 meter on other side of the lens. So the nature of image is real and inverted. The sub question is here. Also find the distance through which the object should be moved to get an image of linear magnification minus 1. So linear magnification is minus 1. What is the definition of magnification? It is height of image to height of object, or it is also V by U. V by U. So here it is given that V by U is equal to minus 1. So if the magnitude of magnification is greater than 1, for example, suppose if magnification is greater than 1, that means height of image is greater than height of object, then we are going to get enlarged image. What type of image we are going to get? Enlarged image. Okay, image is enlarged. If magnitude of magnification is less than 1, that means when you are going to get less than 1, height of image is less than height of object, then we are going to get diminished image. The image is diminished. Okay. So if the magnitude is 1, either it is plus 1 or minus 1, then height of image is equal to height of object. Right. So both are same. That means the size of image is same as size of the object. So image size is not changed. Okay. Height of image is equal to height of object means size has not changed. This happens in case of convex lens. When it happens, suppose if this is focal length, so this is a focal point, and here this is a double of that, 2f, and this is also 2f. So when object is placed at 2f, you are going to get image which is at 2f having same size. Okay, when object is placed at 2 times f, then you are going to get real image inverted and forms at 2f and having same size. Okay, both are having same size, image as well as object. Is it clear? That means here what should be the distance of object? Here the question is find the distance through which an object should be moved to get image of linear magnification minus 1. So f is 0.2 meter, 2f is 0.4 meter, right? Where should be the object? Object should be at 2f. So 2f means f is 0.2 meter, 2 times f is 2 times 0.2 which is 0.4 meter. So if I place the object at 0.4 meter, then I am going to get image at 2f which is having same size, so that magnification becomes minus 1. So where I have kept the object initially object is at distance 0.3 meter. 0.3 meter. So now it should be at 0.4 meter. Initially object is somewhere here, right? 0.3 meter. Now it should be at 0.4 meter means what should be the distance? The extra distance traveled by the object is 0.1 meter. So therefore object should be moved away from the convex lens through a distance 0.1 meter. Is it clear? Object has to be moved away from the convex lens through a distance of 0.1 meter. Extra distance moved by the object is 0.1 meter. Is this clear, student? So like this, I have solved all 4 questions of model paper 2. So if you find any doubt, if you want to clarify anything, so please comment below. If you like my videos, please like, comment and share my videos to others and subscribe my channel. Thanks for watching.